Dear students, today I am taking up chapter 2 of class 12 physics. The topics that I am going to include in this video are electrostatic potential and electric potential difference. In order to understand these terms, I am going to consider a system which has a source charge plus Q and a test charge Q naught. Dear students, we should keep it in mind that both the source charge and the test charge are positively charged. Since they are like charges, they would, if interact, they would exert a repulsive force between each other. Now, in the beginning, I am considering plus Q naught charge to be placed at infinity. My dear students, this test charge Q naught will experience a repulsive force by the source charge only when Q naught comes within the electric field of the source charge plus Q. However, until and unless it comes within the electric field, no external work needs to be done in order to overcome the repulsive force between the two. Now, let us suppose I bring plus Q charge in the vicinity of the electric field of plus Q. When I bring the test charge Q naught in the vicinity of electric field, just as it touches the electric field, what happens? It starts experiencing a repulsive force Fr, which tends to push it away from charge plus Q. However, we aim to bring this plus Q naught charge to a point A within the electric field. So, even we have to apply a force which I am denoting F against this repulsive force so that my charge Q naught moves through a distance dx within the electric field and thus reaches point A. This force which enables the charge to move through a distance dx is actually the work done by the external agent to overcome this repulsive force. Well, my dear students, this external work done to bring the positive test charge from infinity to point A on the test charge is defined as the potential at point A. Thus, I would be defining the potential at point A as the minimum work done on the unit positive test charge to bring it from infinity to the point A against the repulsive force within the electric field. Now, similarly, suppose I have to bring this charge from point A to a further closer point B, then obviously I'll be experiencing a greater repulsive force, and hence I have to exert a greater force in the opposite direction of the repulsive force in order to bring my charge to point B. But why do we experience a greater repulsive force as I approach the source charge plus Q? Well, dear students, this force acting here is the Coulombs force, and we know Coulombs force is inversely proportional to the square of distance between the charges. Now, since the distance between the source charge plus Q and B is shorter as compared to distance between the source charge plus Q and point A, hence we will experience a greater repulsive force at point B as compared to point A. Now, we know work done is equal to force into distance moved. Now since the repulsive force is greater for point B, therefore we have to do a greater work against the repulsive force at point B as compared to that at point A. And since potential at B is defined as work done on unit positive test charge to bring it from infinity to point B, and also since we have found that work done to bring the charge from infinity to B is greater than the work done to bring the charge from infinity to A. Hence, on comparing equation 1 and equation 2, I get VB is greater than VA. However, we have defined the values of electric potential both at point A and at point B. Now, in order to get the generalized formula or the generalized definition for electrostatic potential, we need to keep in mind a few points. Number one, what is being done? We are doing work. What sort of work? Work to bring unit test charge between which points? From infinity to the given point, against what are we doing work? The repulsive force. And where is this work being done? Inside the electric field. Hence, in order to define electric potential at a point in general, I would use these 4 points. Electric potential at a given point is equal to the work done to bring the unit test charge from infinity to the given point against the repulsive force inside the electric field. This gives me the definition of electric potential at a particular point. Now, we are clear with the concept of electric potential at a given point. But what if I want to find the difference between the electric potentials at point A and point B? Well, my dear students, for this I need to introduce a new term, and that term is electric potential difference. As the name itself suggests, electric potential difference, since it is a difference, we need 2 points between which we can find the difference. Now let us consider points A and B. So we need to find difference between points A and B. But difference of what? Difference of electric potential. So let us denote electric potential difference as delta V. Since we are going to find difference between B and A, I'll be writing it as VB minus VA. Now, my dear friends, when I need to find electric potential difference between point A and B, I need to move the charge from point A to point B. Hence, the potential difference would be defined as work done on unit positive test charge in bringing it from point A to point B against the repulsive force inside the electric field. We'll again use these terms, but see how the definition changes. Electric potential difference between 2 points is defined as the work done to bring unit positive test charge from, instead of infinity, point A to point B, rest everything remains same, against the repulsive force inside the electric field. So, in general, we can define electric potential difference between 2 points as the work done in bringing unit positive test charge from one point to the another point against the repulsive force inside the electric field.